Hello students and welcome to Lesson 5 of Unit 3. In this lesson we will continue learning how to simplify algebraic expressions, and today's focus will be on multiplication and division properties. You will learn two properties that will help you to simplify more complex algebraic expressions. Before we begin, I would like you to recall the definition of terms. Terms are parts of an expression that are being added or subtracted. Multiplication and division can be part of one term. So for example, in the leftmost example here we have 2x plus 3x. This is two terms. You'll need to add these notes to your guided notes. In this expression we have 2x times 3x. This is one term, and we learned earlier in Unit 1, Part 2, that we can simplify this. 2 times 3 is 6. X, which is x to the first, times x to the first makes x squared. So you can see if you look at it this way, it does look like one term. Now, before we get into our new properties, I need you to remember and recall three of the properties we learned back in Unit 1, Part 2, Lessons 3 and 4, because they will help you with today's lesson. The first is what we do when we have multiplication of the same base. So for instance, if we have a to the m times a to the n, what do we do to simplify this expression? And like we learned in the last slide, this is just one term because there is no addition or subtraction. So how do we simplify multiplication of the same base? Well, we keep the base the same and we add the exponents. The second property that will help us today is division of the same base. So if we have the same base being divided, we can simplify it by writing that same base and subtracting the exponents. Now, remember, there is a trick to this property, and that is the base will always be where the greater amount is located. For example, if the greater amount is in the numerator, then this expression will be in the numerator. If the greater amount is in the denominator, then this will end up in the denominator. And the last property that we learned about that will help us today is reducing by a common factor. So for example, if we have 35 over 20, we can see that both of these end with a 5 and a 0, so we can reduce them by 5. 5 is the common factor, the number that both will divide by, to get 7 over 4. So that's an example of reducing a constant by a common factor. Now, this is what your chart should look like filled in, and we're going to use that to practice 4 review questions. In number 1, we see a to the third times a to the fourth. Notice there's no multiplication sign in here, but because they are touching, we know it means it's multiplication. So this will be equal to the same base to the addition of the exponents, 3 plus 4, to get a to the 7th. Some of you are able to skip writing this step. Some of you still are writing that, and that's okay too. Now let's look at division of the same base. If we have a to the 6th divided by a to the 8th, we can subtract the exponents and place them where the greater amount is. So we'll have the same base, which will be a, and 6 minus 8, or 8 minus 6, is 2. So we're going to have a to the 2nd, and we're going to place it in the denominator since a to the 8th is greater than a to the 6th. So we have a squared, 1 on the top to hold the value. Now, as you can see in our third example, this expression looks very similar to number 2. The only difference now is that the greater amount is in the numerator. So when we simplify, our base is going to end up in the numerator as well. So this is going to be equal to a to the 2nd power because the greater amount was in the numerator. Now here in number 4, we are going to be combining all 3 of the review properties that we talked about. First of all, we see multiplication of the same base here. So let's simplify that and rewrite our expression. So we get 3a to the 7th, because we added the exponents, over 6a. Now we also see division of the same base. Here we have a to the 7th divided by a, which is a to the 1st. 7 minus 1 is 6. We're going to get a to the 6th, and we're going to place that in the numerator since the greater amount is in the numerator. So we have 3a to the 6th over 6. And last, we see our common factor rule because we have 2 constants that both can be divided by 3. 3 divided by 3 is 1, so we get 1a to the 6th, or just a to the 6th, over 6 divided by 3, which is 2. So this simplifies to a to the 6th divided by 2. Now let's look at our 2 new properties. Our 2 new properties are named the distributive property, which is a multiplication property, and the shared division property, which is a division property. Both properties are alternatives to the order of operations, and I'll show you what that means in just a minute. So let's look at the distributive property. The distributive property is always used with multiplication of a sum. So here you see that 3 is multiplying the entire sum of 4 plus 2. Now, order of operations says that we need to do the parentheses first. And in this case, since they're all constants, we can, because constants are like terms. So 4 plus 2 is 6, and 3 times 6 is 18. The distributive property is an alternative to doing an expression using the order of operations. Instead of using the order of operations, we can multiply each term by the factor they share. So for example, we had 3 times 4 plus 2, and you'll need to add this to your guided notes. We have 3 times 4 plus 2. Instead of adding what's in the parentheses first, we can multiply each of these terms, see the 2 terms inside, by the factor they share. They both share times 3. So instead of adding first, we can take 3 times 4 and add 3 times 2. And if you simplify this, we'll see that we get the same thing. 3 times 4 is 12, plus 3 times 2 is 6. 12 plus 6 is 18. Now, with a numeric expression like this, it does make it longer to use the distributive property. But when we have an algebraic expression, the distributive property is our only option, since these will not be like terms. So algebraically, this is how you can represent the distributive property. If you have a number times the sum of 2 other numbers, then it's equal to the factor times the first term plus the factor times the second term. And this property can apply to more than 2 terms, but in general you would just have to give that factor to each term inside. So let's practice using the distributive property. Here I've reminded us of the definition and algebraically the way it looks. So let's practice 4 different problems. So here we see the distributive property because we have 3 times a sum. So we're going to give the 3 and multiply it by each one of the terms. And I like to draw arrows so I don't forget to multiply by every single term. So we have 3 times x. Well, how do you write 3 times x? 3x. And 3 times, and always look at the sign in front, positive 5. 3 times positive 5 is positive 15. So simplifying this expression is equal to 3x plus 15. Now, in our second example, this does combine what we learned and reviewed about multiplication division properties. So in this case, we do have a factor times a sum. Now, this is just a sum of a negative amount. That's what subtraction is. So just grab the sign in front and you'll see what I mean. So we have 2x times x squared. So we have negative 2x times x squared. I'm just going to write it like that for a moment to show you how you can shortcut this as well. Do you see how we have x times x squared? X times x squared. That's the same as x to the first times x to the second, and we learned that a to the m times a to the n is equal to the addition of those exponents. So this is the same as negative 2x to the third, because there are 3 x's being multiplied. Now we also have to multiply negative 2 by negative 2x by negative 3. So we have negative 2x times negative 3. Well, what's negative 2 times negative 3? Positive 6, and then just bring your x along, times x. So here is our simplified expression, negative 2x to the third plus 6x. I'm going to erase this just to relieve some of your visual clutter here. Okay. Now, in example 3, you see the distributive property twice. If you look just at the leftmost portion, you see the distributive property once, and if you look at the rightmost, you see the distributive property a second time. Let's look just at the first part. We have a factor of 4 being multiplied by both x and negative 8. So let's simplify. 4 times x is 4x. 4 times negative 8 is negative 32. Now let's look at the rightmost part. We have a factor of negative 2. Notice how I grabbed the sign in front. Times x and negative 2 times positive 7. So let's simplify those parts. Negative 2 times x is negative 2x. Negative 2 times positive 7 is negative 14. Now, unlike our first two examples where we just had the distributive property once, we now have an expression that contains like terms, like we learned about in the last lesson. So we see 4x and minus 2x. 4x minus 2x makes 2x. And we also see constants, negative 32 and negative 14. If you owe 32 and you owe 14, then you owe 46. So this expression is equal to 2x minus 46. Now let's look at our last example. This example is very similar to the third one that we did, with the only difference being that our factor contains a variable. So we have 2x times 3x and 2x times positive y. Now, 2x times 3x, 2 times 3 is 6, and x times x is x squared. Think about adding the exponents, x to the first and x to the first. Now, we have to do 2x times positive 1y. 2 times 1 is 2, so we have positive 2, and x times y cannot be simplified, so we just write x times y or xy. Now let's look at our second portion. We have negative y times 2x, which is negative 2xy, and negative y times positive 7x. We get negative 7xy. We then just need to simplify our like terms.